Hello, we are going to be talking about IV rate change. This will only happen when we are dealing with a gravity flow IV. When we're using an infusion pump, the pump will automatically adjust to the patient's movement and it'll adjust the pressure and therefore adjust the rate so that it stays right on track. When we're dealing with gravity flow, as the patient moves, the IV will adjust slightly, and then we as the nurse want to come in and make sure that the IV is on track. So we may need to adjust the IV slightly up or down so that it remains as the doctor has ordered it. Our protocol that we're going to use here in the classroom is a change of 25% or less is acceptable without consulting the doctor. That means that anywhere from negative 25% up to positive 25% is our acceptable amount of change. So let's take a look at an example. As we read this problem, we see that 500 milliliters of normal saline was ordered to infuse it in 8 hours at a rate of 16 drops per minute. The drop factor is 15 drops per milliliter. We already talked about that. That's one of the macro drip tubings. And then we have this last sentence. After 5 hours, you find that 250 mLs of fluid is left. So I find it incredibly helpful to organize the information into a chart because there are so many numbers given in the problem, and it just helps me understand everything that's going on. You'll find that next week on your quiz, I already drew the chart for you. So you do not have to memorize the chart, but I encourage you to draw one in your scratch work and use it for homework. In the chart, we have a column for what is ordered, and we'll be filling in all of the ordered information. And then we have a column for what is remaining because we'll use the remaining time, the remaining volume, to come up with a new drop per minute rate that would get the IV to finish on time based on the original order. So I'm going to read back through the problem. This time I'm going to fill in the information. So it starts out with 500 milliliters. So that gives me the volume that's ordered. So I'll fill in the 500 milliliters right here. It was ordered to infuse in 8 hours. So I'll fill in the 8 hours as the time. At a rate of 16 drops per minute. So I'll fill in the 16 drops per minute. So the entire ordered column is filled in. So the 500 milliliters per hour, doctor's order, or per 8 hours, excuse me, doctor's order, nurse has already calculated and set the IV at 16 drops per minute. Now I jump down to the last sentence, after 5 hours. So if I take 8, subtract 5, that means that there would be 3 hours remaining. You find that 250 milliliters of fluid is left, so it actually tells me the amount that remains is 250 mLs. So the thing that I need to calculate is the new drop per minute rate. The way that I do that is I take the information that I have for the remaining. So I take the 250 mLs and I divide it by 3 hours, just like I were finding the milliliter per hour rate. But because it is a gravity flow IV, I need drops per minute. So I have to do 2 conversions. My first conversion is the time. So I know that 1 hour is the same as 60 minutes. That allows me to cancel the label of hours. From the problem, the tubing gives 15 drops per ml. So that will allow me to change the mLs into drops so that I can count them in the drip chamber. So that cancels ml. So I go ahead and do my math. So I multiply across the top, across the bottom, and do the division. Because I physically need to be able to count these drops, I have to round to a whole number. So my rounded answer here is 21 drops per minute. So if I would reset the IV at 21 drops per minute, provided nothing else happened, this IV would finish within the 8 hours like it was originally ordered. But before I can do that, I need to check how big of a change is this. So to do that, I use my percent change formula, which is new minus old divided by old times 100. So my new value was 21. My old value was 16. Divide by 16 times 100. On my calculator, I have 5 over 16 times 100, and that gives me 31.25%. So based on our protocol, this change is more than 25%. So before I make that change, I need to consult the doctor. So my course of action is to consult the doctor. It is the doctor's decision if the IV should be sped up, if it should be reset at 16 like it was originally ordered, what should be done with that IV. So for these problems, I focus on organizing my information, and then in order to do the drop per minute calculation, I start with milliliters per hour, and I do the 2 steps of dimensional analysis, making sure to round my answer to a whole number.